Alright, how's everybody doing today out in mathematics land? Today, Mr. Muscarella is going to take you on a trip for application problems for conics involving the ellipse. Now here's a really long word problem. So let's go ahead, you'll probably hit pause and read it, but I'll go ahead and read it aloud for your entertainment. An arch for a bridge over a highway is in the form of half of an ellipse. The top of the arch is 20 feet above ground level, the major axis. The highway has 4 lanes, each 12 feet wide, a center safety strip 8 feet wide, and 2 side strips, each 4 feet wide. What should the span of the bridge be, the length of the major axis, if the height 28 feet from the center is to be 13 feet? Oh my gosh. Did you just die a little bit inside because you read all of that and have like really no idea what's going on because there's just numbers all over the place? Fear not. Let's get through this together. First thing that we're going to do is we're going to draw a picture. And when you go to draw a picture, we always want to put the shape that we're told here. We're going to put that so that it's centered at the origin. Now there's 2 numbers we're going to pay attention to here. One is the top of the arch, 20 feet above ground level. And we're going to skip all this stuff about the highway for a second. And we're going to go to the other part that asks the question. What should the span of the bridge be, the length of the major axis, if the height 28 feet from the center is to be 13 feet? So that's going to kind of give us a picture that'll look like this. Now, 20 feet above ground level, that's just going to be 0, 20. And then my other coordinate point, 28 feet from the center, has a height of 13 feet. So that's going to be these coordinates right here, 28 feet. And then 13 feet high, because that's this little spot right there. And it's 28 feet over. Now, a couple things that I know about my ellipse already, or my half of ellipse, from the ground to the top of it, I know that's a height of 20, so that spot is what's going to be my B value. Now, the entire length of my ellipse from one side all the way to the other. That's what I'm trying to figure out is basically, what should the span of the bridge be? And a lot of people make this mistake right here. They'll take a picture and they'll say, all right, well, I've got these 2 4-piece lanes or 4 side strips that are 4 feet wide. I've got the 8-foot wide piece in the middle and my 4 lanes that are each 12 feet wide, and I add all that up, 4 plus 12 plus 12 plus 8 plus 12 plus 12 plus 4, I add all that up, and I get 64 feet. And they're like, oh, that's it, I'm done. Because I can add, and that number makes sense, 64, but actually, that's not correct. That is going to be what the minimum distance is going to be, because our arch has got to cover at least, that bridge has got to cover at least that width, and probably more. So to do that, to figure out what the actual span of the bridge is going to be, we're going to use one of our handy-dandy formulas about ellipses. And everybody knows this one. Now, if it's centered at the origin, we don't have to worry about this HK stuff because H and K are both 0. So that's just going to give us x squared plus y squared in the numerators, and then the a squared plus b squared in the denominators. Okay, and remember, for your ellipse, it's set equal to 1. Now, here's where I want you to pay attention a little bit to some of the numbers that we have. Now, the 0, 20. 20 is going to represent the height above my major axis, so that's going to go in for B. And then the 28, 13, that one particular coordinate point, or the height from the center, 13 feet high, that piece is going to go in for our x coordinate and our y coordinate. Now, the only one we don't have then is just our a squared. Now, a, and this is where you have to kind of think about this a little bit, a, remember, is going to represent the distance from the center all the way to the end of our ellipse. So if we want to know the span of the bridge, really what we want to know is the length of 2 of the values of a. So we got to find a, whatever that is, and then we'll just double that, and that'll give us the length of the span of the bridge. So from here, this is just going to turn into a really simple algebra problem because we're just trying to solve for one simple variable. Now, here's one way to go about it. We'll simply square everything we've got. We've got the 784 over a squared plus 169 over 400 equals 1. Now here's what I want you to kind of pay attention to. If the a squared's in the denominator, here's one way, and this is just the way that I go about doing it. You might go some other crazy way, but it's all just numbers, and we're just playing with the numbers right now. So I'm going to take that 169 over 400, and I'm going to move it over to the right-hand side. Now, notice I took the number 1, and I re-represented that as 400 over 400, because 400 over 400, if you reduce it, is just 1. And then when we perform our arithmetic, the 400 minus 169, so we have our common denominator, you subtract, you end up with 231. So now I just have this cross product, and you guys remember this from probably your early days of working with proportions. You simply cross multiply and divide. We're going to have one other square procedure to do because it's not just a variable, but that variable squared. So we end up with 231 for a squared equals 313,600. And when we divide by 231 and take the square root, we end up with about, now notice I changed my symbol there, about 36.8. And a lot of people are like, oh, well, like, yeah, I'm done because I got A. Psych, no you're not. Remember, the length of the span isn't just A. The span of that bridge is double that. You know, basically what you do is, all right, I'm just going to kind of go up here for a second. So if A is 36.8, then double that would be about 73.6. Now, depending on how you did this in your calculator, you may have ended up with like 73.7 if you did your rounding. Either way, it's okay, but don't think that you're done there yet either. You've got one more thing to do, and that, boys and girls, is to answer the question in a complete sentence. And you better be including units in that sentence. So then wrapping it up, we would write the sentence similar to this one. The span of the bridge is about 73.6 feet. Now, if you wanted to round that to 74 feet and say the span of the bridge is about 74 feet, that would be okay as long as you use that word about. So sometimes directions will specify how many decimal places to go out, other times it won't. So please make sure you read the directions and interpret the question correctly. Make sure you write your final answer in a complete sentence and include the units. Now that was a lot for this one question, but take your time and I think you'll get it. It just takes a little bit of practice. Thanks for watching, and I'll catch up with you guys later. Peace out.